In today's lesson, we want to find the equations of quadratics. Since we have three different forms of a quadratic, we need to know under what conditions would I choose to express my quadratic in vertex form as opposed to standard form as opposed to factored form. Typically, if you're given an equation where they give you the vertex, so if one of the pieces of information you have is the vertex, you're going to want to go and express your quadratic in vertex form. If, however, one of the information that they give you is the roots, you're going to want to express your quadratic in factored form. And lastly, with standard form, you're typically going to use standard form if you are given several points. So if you're given several points, then you can go ahead and express your quadratic in standard form. Okay, let's look at some of these examples. The first example here says find the equation of a quadratic with a vertex at 0, 3 and passes through the point 2, -5. Okay, so they gave us in this question the vertex. So I'm going to go to vertex form. So vertex form is y equals a, x minus h quantity squared plus k. Now they've given me my vertex. Well, your vertex here is expressed as h and k. So what is my h value here? Well, this is my h and this is my k value. So if I sub that in to my vertex form, we're going to get x minus 0 quantity squared plus 3. Well, I can simplify that. X minus 0 is just x, so I can write this as a x squared plus 3. I can drop the brackets because we've only got the one term inside. So now our quadratic is already looking much simpler. I need to find this a value. Well, the only other piece of information they gave us here is that it passes through the point 2, 5. Well, I'm going to sub that point in. Right? I'm going to sub that point in because this is a point on the quadratic, so therefore the equation holds. So I'm going to let y equal -5, and then I'm going to let x equal 2, and then we're going to go ahead and solve this. So this becomes 4a plus 3. Again, you always put the number in front, and then we're just solving for a here, so subtract 3 on both sides. Then we can go ahead and divide across by 4, and I get my a value here is -2. So therefore, we have a quadratic. Let's write up our answer here. Therefore, what's our answer? Well, it's y equals -2, x minus 0 squared plus 3, or you can simplify it. You don't need to write that 0. And we have our quadratic in vertex form. Note, this is still viewed as being in vertex form because you can just put that -0 there, and it would match what we've discussed as vertex form. Okay, so here's an example where you're given a vertex and you're given a point, and you find the equation of your quadratic in vertex form. All right, let's look at the next example here. So now again, find the equation of the quadratic. This time they use the term roots, and we have roots at -1 and 5, and it passes through the point 3, -4. So now with this question here, they gave me the roots, so I'm going to go to factored form. Well, factored form is y equals a, x minus r, x minus s. These are my roots. So I need to create a quadratic that has a root at -1. So I'm going to put a +1 here. And the reason for that is if I were to go ahead and solve for x here, you would have to isolate for x. You would have to set it equal to 0 and solve for x, in which case you get -1. Right? Likewise, if I want to have a root at if I want to have a root at 5, I would have to put in x minus 5 here. And again, the reason for that is now if I go ahead and solve for x, I would have to isolate for x, and then my root would be 5. Had I put a x minus 1 here, which commonly students want to do that, they just want to put a -1 here. If I would have gone ahead and solved for x, I would have ended up getting x is equal to 1, which isn't what I wanted. And likewise, if I were to solve for x for this equation, if I would have put an x plus 5, when you go ahead and isolate for x, you would get -5 as your root, which would be wrong. Okay, so now I've got my r and s values here. I want to go ahead and solve for my a value like we did in the previous question. I'm going to go ahead and I'm going to sub this point in. This is a point on my quadratic, so I can sub it in. So when I sub this in here, y equals -4. x is equal to 3. And I end up getting negative 4 equals a times 4 times negative 2. And now we got here negative 8a. I can go ahead and solve for a. I getting here a is a half. So my a value comes out to be a half for this question. So putting this together, we now have our answer. My quadratic is y equals 1/2 x plus 1 x minus 5. So this is the quadratic that has roots at -1 and 5 and passes through the point 3, -4. So for this question here, they want you to find the equation of a quadratic that has an axis of symmetry of 1 and it has a root at 6 and passes through the point 5, -18. So there's a little more going on in this question. First of all, they gave us the axis of symmetry at 1. So how can we use this to actually find our equation? Well, what do we know? I don't know whether this quadratic opens up or down. We can talk about that later, but I know that, let's say it does open up, for instance. If I have an axis of symmetry of x is equal to 1, and let's say this is my one root at 6, I know that the other root, since this is the line x equals 1, the other root is exactly the same distance away from the axis of symmetry. That's part of your symmetrical property. So for me to go from 6 to 1, that distance is 5 units to the left. Therefore, the distance to my next root must be 5 units to the left. Well, if I'm at x equal to 1 and I take 5 steps to the left, this point here must be -4. So there's a lot that they're telling you here. When they tell you a root and they tell you your axis of symmetry, you can quickly figure out the other root of the quadratic. So in this situation here, really what they're saying here is this quadratic has roots at 6 and -4 and passes through the point 5, -18. So now this question is really just an older type of problem now that we just have done. Now I'm given 2 roots and a point. So now just like we did in the previous example, you would proceed. So now my equation is y equals a, x minus 6, x plus 4. And notice here, if I solve for x, I get a root of 6. If I solve for x, I get a root of -4, which is what we want. Now I can go ahead and sub the point in to solve for my a value. Your x value here is 5. And I can go ahead and solve for a here, so I get -1 times 9, so I get -18 is -9a, so I'm getting a is 2 here. So putting this all together, we have our answer. The answer to this question is y equals 2, x minus 6, x plus 4. Okay, and this is an example of essentially you're just given, really you're given 2 roots and a point, but they kind of disguise it with this axis of symmetry. So that's kind of a cool problem. Let's take a look at the next. So in this equation here, it says find the equation of the quadratic that has roots at -1 and 1 and has a y-intercept of -3/2. So again, they gave us 2 roots here. And the reason this problem is interesting is they gave us 2 roots. So I'm going to go to my factored form. So here I have roots at 1 and -1. I want to find my a value, but they didn't really express it as a point. Well, the question becomes is, how do you express your y-intercept as a point? Well, take note here, if you have anything at all, no matter what it is, but let's pretend it's a quadratic, and that quadratic crosses the y-axis, that has the property that its x value is 0. I don't know what the y is in general, but any quadratic you have, no matter which one you draw, has the property that where it crosses the y-axis, so in this case, right here, for instance, I don't know what the y-coordinate is, that's what I want to find, but I know that its x-coordinate in general is 0. So therefore, if someone tells you you have a quadratic that has a y-intercept of -3/2, really they're saying the quadratic crosses through the point 0 minus 3/2. So now I can sub this point into my equation, and I can go ahead and solve for a. So in this case here, we get -3/2 equal -a, And I can divide across by negative 1, and I get a is 3/2. So the answer to this problem here is going to be y equals 3/2 x plus 1, x minus 1. Okay, so this is an example of a quadratic given roots and a y-intercept, which is really just giving you a point, and that was the key to this question here. All right, let's take a look at another. So in this question here, they want you to find the equation of a quadratic that has a y-intercept of -7 and passes through these 2 points. So now, just as we talked about already, we know that saying that you have a y-intercept of 7 is equivalent to saying that you pass through the point 0, -7. And we also have the point 1, -6, and we also have the point -1, -9. So in this question here, they really gave us 3 points that my quadratic passes through. So we're going to go to standard form. So in standard form here is y equals a x squared plus bx plus c. Now I have a y-intercept of 7. If you sub this point in here, your y value is -7. My x value is 0. And you'll notice here, everything here cancels. We end up getting my c value is -7. Okay, and that's a property of standard form. Your c value, your constant term, that's always going to be your y-intercept. So when you see that you have a y-intercept of -7, you can just change the c value to -7 right away. But this is the math behind it and why that's the case. Okay, so now I have a quadratic that we've already found one of the 3 variables, y equals ax squared plus bx minus 7. So now I want to find the other 2 values here. Well, this is a point on my quadratic, so I can sub it in. So let's go ahead and sub that in here. If I sub that in, I'm going to get y is -6 and a is 1. So my a value is 1, or sorry, my x value I should say is 1. So I get y is -6 and my x value is 1. So I'm just subbing a 1 in here. And we get -6 equals a plus b minus 7. I'm going to add 7 to both sides, in which case I get a plus b is 1. Okay, let's take a look here. I've got this one equation here I'm working with. Now what I want to do is I want to do the exact same thing. So in this example here, we substituted in the point 1, -6. Now what I'm going to do is I'm going to substitute in the point -1, -9 into my quadratic. So now everywhere I see a y, I'm going to be changing that to a -9 and change my x value to a -1. So this is going to be -9 equals a times -1 squared plus b times -1 minus 7. In which case we get -9 equals a minus b minus 7. I'm going to add 7 to both sides. I get -2 equals a minus b. So now you notice here, I'm looking to solve for a and b here. I actually have 2 equations. I have a plus b equals 1 and a minus b equals -2. So if you remember, we've discussed solving systems of linear relations. Again, if you've missed that or you need a refresher on how to solve that, I'll link that in the top right-hand corner and you can access that video. But I want to solve this system of linear relations here, and to solve this here, you have 2 equations. My first equation is a minus b equals -2, and my second equation is going to be a plus b equals 1. We can solve this using substitution or elimination. I'm going to do elimination on this. I'm going to add up my equations, in which case I get 2a. The b's will cancel, is -1. So I'm getting a equals -1/2. So we already found our a value, -1/2. And then I'm going to go ahead and sub this in and solve for b. So if I sub this in and solve for b, you get -1/2 plus b equals 1. b equals 1 plus 1/2. I'm getting b equals 3/2. So putting this all together, my answer here, the quadratic that has these properties, is the quadratic y equals -1/2 x squared plus 3/2 x minus 7. So this is the quadratic that has a y-intercept of -7 and passes through the point 1, -6 and the point -1, -9. So that concludes the lesson here. I went through several examples here. Take note of them, study them. Even maybe watch the video again, try them out yourself, see if you can do them from scratch. But at any rate here, this covers finding equations of quadratics, given a vertex and a point, given roots and a point, given 2 points and a y-intercept, and even given your axis of symmetry and a root and an additional point. All right, thank you.